So let's look at this example, actually taken from the exercise question number 4a. We use the idea that we thought about already algebraically and split the 4/3 in 1 over x squared. So this is the integral of 4/3 times 1 over x squared with respect to x, like we did before. So separate out the 4/3 and 1 over x squared. The 4/3 is a constant, so that can effectively come outside the integral. All we're left with to integrate is the 1 over x squared. You might be tempted to think, that's like the standard integral 1 over x, which is log x. But it's not 1 over x, it's 1 over x squared, which makes a big difference. What we use here is the law of indices, which says that 1 over x to the n can be written as x to the power minus n. That's that second law of indices. One we use all the time is the root one. The other one we use all the time is this inverse one. So actually what we do is we rewrite this as 4/3 times the integral of x to the minus 2 with respect to x. And so now we apply the first rule. Add 1 to the power and divide by the new power, Howard. So minus 2 plus 1 is minus 1. Not minus 3, minus 1. So minus 2 plus 1 is minus 1. Divide by minus 1. So this becomes 4/3 times x to the minus 1 over minus 1 plus c. Adding 1 to the power and then dividing by the new power. I wouldn't leave it like that because I'd multiply these two fractions together. 4 times x to the minus 1 over 3 times minus 1. So effectively comes minus 4/3 x to the minus 1 plus c. But x to the minus 1, that's correct. But x to the minus 1 means 1 over x, doesn't it? From that inverse law, minus 1 means the inverse. So I can actually finish off by writing this as minus 4/3 times 1 over x plus c. And then recombine them and call it minus 4 over 3x plus c. So you might be tempted to think an example like that is using the inverse standard integral log, but it's not. That only works for 1 over x, simply that one. So another power like x squared becomes x to the minus 2, and then we apply the normal rule to integrate it. So